to only include the volumes that you specify. In this case, I'm saying 1, so counting from 0, that's the middle one, the T-map. And I'm going to write, I'll just call it foo. And we're going to overlay that on the column brain, and we can set the threshold to, what was it, 2.88? So now you'll be able to see all the voxels that met this fairly stringent threshold of Q equals 0.15. And of course, bear in mind that when your Q is 0.15, it means that the expected number of false positives among all these ones that you see highlighted is about 15%. The other thing you can do here in VBView, or I'll show you how to do the command line, is just hit Control-I, and you'll get a display of all the regions that are made up. And what a region is basically a set of contiguous voxels that are above your threshold. This text display is not always incredibly helpful, because sometimes they can get very long if you have lots of different scattered voxels. But in this case, we have 5 regions. Some of them have 1, 2, 18 voxels, 2 voxels, 2, and then this big region, which has 22,666 voxels. So that's it gives you some summary information about each of these regions that may be helpful for reporting. I should mention that right now the coordinates for these regions, for like the center, the weighted center, etc., the peak center, the coordinates for these regions are from the corner. So the corner voxel being 0, 0, 0. At some point, I'll add a feature to have it automatically convert to MNI coordinates or origin-adjusted coordinates. But right now, it doesn't do that. By the way, the cheat sheet, which I keep meaning to put up on the wiki page for this workshop, has a list of all the coordinates and all the different template sizes and their canonical origins, which I find incredibly helpful, because I find myself constantly looking that up. As long as I've been doing this, I never remember. So you may remember that I sort of advocated doing things more than one way. I haven't done very much of this stuff more than one way, but I've tried to include a few things that I would describe as checks and balances to verify the sanity of things. But you can also carry out these same analyses using regression. There's a separate program in Voxbit called VbVolRegress. It's actually kind of useful, because it'll do regression using any combination of 4D files and 1D files. And what this means is, normally when you do a regression, you'll have a few vectors, a few series of numbers that you want to regress on, one on the others or something like that, or vice versa. VbVolRegress lets you replace any or all of those with 4-dimensional volumes, as long as the dimensions are the same. Which just means that you're still carrying out regression of vectors, but the vector changes from voxel to voxel. So in this case, it's exactly what you'd expect from a VLSM analysis. You're taking the vector at a given voxel, which is just a vector of which patients are lesioned there, and looking at the linear relationship between that and some dependent measures. So the syntax for VbVolRegress is a little convoluted, and I'll just sort of go over it briefly, but it allows you to specify one dependent variable, which we've used continuous.ref again, as many independent variables as you like. In this case, we have only one, our lesion data, and we've added this flag int to say that we want an intercept, which will give us those three in combination give you the equivalent of a t-test. And then here's the really cryptic part. This -c option tells VbVolRegress how you want to weight the different coefficients to create your statistic. So in this case, we've given it the arbitrary name foo, which I use a lot. We've said we want a t-statistic. By default, that's one-tailed. And then we're going to specify the weights as a vector, and here's our little vector of weights. So what this basically means is that if you look at the independent variables, which are lesions.tests and the intercept, we're going to weight lesions.tests -1 and the intercept 0, which is kind of what we want. We want to test the lesions. So when I hit return, you can actually take a quick look at the contrast for sanity and see that the things that are in the model are the right things, and that they have the weights that you wanted. You can sort of see that right here. You don't get information from VbVolRegress about the number of independent comparisons, because it's a general purpose regression program. It doesn't know anything about lesions. Possibly it could have been clever enough to notice that your values, one of your independent measures, were all zeros and ones, but it isn't. Anyway, when it's done, it produced this file called the regression tmap, which is just the file I told it to produce. I'm going to run this command one more time, changing one little thing. So what I've now, TP2, is that really what I wanted? Should be TP1. Well, what I've now done is I've changed the contrast to, instead of T, I've said TP2, which means it's, instead of a one-tailed Tmap, it's giving a two-tailed Pmap. I should probably make it one-tailed just to be kind of the same thing. Okay. Just takes a second. VbVolRegress is a little slower than Vbtmap because it's doing a regression which is a little more complicated. And I should highlight this new program that I added to VBvoxbo called Vbtool, which has really kind of random functionality. It's just little things that didn't fit anywhere else. One of the cool things is Vbtool Tip, which gives you a random tip about Voxbo. You can add your own tips by creating a little text file. So I don't know that I find that so useful, but occasionally I put things in there that I want to remind myself of periodically. And I added one in that reminds you to duck, which is really useful sometimes. One of the other arguments you can give it instead of asking for a tip is contrast, which tells you how to specify those contrasts. Tells you what some of your options are and so on. So that's, as long as the syntax is going to be that cryptic, it's good to have this around.
Dan, did you say anything about the form of the input for the if you had multiple independent variables?
No. Did I? No. I will in a minute, though. Okay. But really, you can give this -iv argument as many times as you like. So if you have some nuisance covariate called foo, you just give it another iv that says foo.
And it will go look for it. I mean, it will go look for a file. I'm just wondering.
Yeah, you give it the file name.
So that's the file name.
Yeah. And I'll show that in a minute. So it's actually useful to figure out if we've really done the same thing as we meant to before, done the same thing as before, as we meant to. And there's a useful Voxbo program for this called Vbcmp. Vbcmp is actually a kind of clever little program that will take two files. The files could be 3D files, 4D files, vector files. It'll compare the data and either tell you they're identical, or if they're not identical, it'll kind of tell you how they differ. So if I make a nonsensical comparison between the tmap and, I need to find something of the same, what do we have? And that foo file, I don't remember even what was in that. Great. I guess true is going to be the same thing. Oh, mask, here, this mask. Okay, I know the mask is different. It'll tell you what proportion of the voxels are different, what the mean difference is among the voxels that are different, and what the maximum difference is among the voxels that are different, and where that was found. You can see that even using the mask and the tmap, the proportion of different voxels is still very small, 2%, because most of the voxels are zeros. Our lesion coverage is not the whole brain, and certainly didn't include air. I don't know if that's the most helpful measure, but.
Yeah, I'm not sure I followed why you would ever want to use the regression tool, since one of your variables is categorical. It seems like a t-test would always be the appropriate.
Right. Well, so sometimes, well, I guess sometimes you may not have a categorical dependent measure.
But the lesion map is always.
Right. Right. But you could have continuous value lesion maps, but more likely you might have a nuisance covariate that you'd like to include, and that would tend to be continuous. So let me. Gee, we already did this, I think. Let me. Oh, this is just the way to look at the region info using the command line. Let me set that to. I can't remember what the threshold was. Well, so the VBIM command can create these region summary descriptions at the command line. It's very helpful because, as I said before, you don't always want to have to go surfing through a graphical interface just to get some region information. And if you want to, you can calculate the region info not for contiguous voxels, but for all the voxels in a mask. So let's not threshold it, and let's just say we want to get a region information for everything in the mask taken together. So this is that. Again, nonsense data. I have nothing to say about the actual numbers there. It's sometimes helpful to actually do these analyses in a separate program. It's really easy to do for some things. I mentioned you could do it in R. If you want to do just a single voxel just to convince yourself that you're getting the right answer, really not that hard. So here's a little program called Vbxts, which grabs the time series for a single voxel. In the case of a lesions file, it's not really time, it's a subject series. And I picked out this voxel 142, 11790 because I clicked around for a little bit and found out that it had some data in it. So I'm running that. I've created a little file called randomvoxel.ref. I guess I just admitted that it wasn't random, but still. And then we can run R, and all I'm doing in R here is I'm loading up this thing called randomvoxel.ref. I'm loading up continuous.ref, and I'm running a simple linear model. So it's the same thing as a regression. I guess I could have. There's probably a way to do it as a t-test, but there we go. I don't know why it took that long. And you can see that we have a t-value of -3.662 and a p-value of 0.00137. Maybe it would be helpful to... What do we have in our directory here? Do we have a pmap? Did I even create a pmap? Oh, regression pmap. Oh. Okay, so I'm going to load the column brain with both the tmap and the pmap as overlays. The pmap doesn't really make a particularly compelling overlay, but I'm going to do it that way anyway. Now I probably should have tried to remember where that voxel was. I don't really have much working memory. 142, 117. Almost. Okay, so let me just this. Oops. 42, 117. Okay. And oh, yes, now I remember why I had that set to a two-tailed t-test, because that's the default in R. Right, so you can see that the stat value came out the same. Actually, it was negative in R, it's positive here because I flipped it when I did the regression. And the p-value here came to exactly half the p-value that R reported because I very cleverly did a one-tailed test. But of course R can also do a two-tailed test, if I remember the syntax. Where did that go? Does anybody remember the syntax for requesting a one-tailed test in R? Oh, trust me, it comes out exactly right. So there you go. Voxpo and NPM and R all come to the same conclusion regarding that voxel, and it turns out they also all come to the same conclusion for other voxels as well. I didn't choose this voxel advantageously. Nothing up my sleeves. It's all very simple. So